So hello everyone, welcome to this video, and in this video I will be explaining the problem maximize number of subsequences in a string, which was asked in bi-weekly contest 74. In today's contest it was the second problem, very nice problem. So if you see, so first I will be explaining via the whiteboard and then I will be coding it. So if you see that this problem is actually a dynamic programming problem. The problem genre of this is the LCS, longest common subsequences problem. So there is another problem on LeetCode, LCS. So it is a variation of this problem. So basically what is being asked is that suppose you have been given a string A, B, C, D, B, C. So you have to insert, and this is a pattern. So you have to insert this A somewhere in the string such that the longest common subsequences will be maximized. So suppose if I insert A here, the number of common subsequences will be like 4. These are the subsequences. Suppose A and C, this is 1, and suppose if I choose this A and this C, this will become 2. And so let's say we have 2 here. Now if I choose this A and then this C, then this will be 3. If I choose this A and this C, then it will be 4. So there the answer will be total 4. So another observation here will be that you have to insert A and C. You can insert one of these only. Okay, so and if you see the time complexity for this problem, the length of this problem is 10 raised to power 5 and the pattern's length is 2. Okay, I will get to the time complexity in a while, but this gives us a fair idea that the time complexity cannot be big O of n square. Okay, it should be big O of n. So then I've started thinking that okay, it definitely means that it will not work. Suppose so earlier I was thinking that I will put A here, then count the number of subsequences. I will put A here, then count the number of subsequences. So this will make the time complexity equal to n square. Okay, so if you look closely, you will realize that the best bet will be, if the A is here, the best bet will be to put A here. So if you put A here, then you will get the maximum number of common subsequences. You can just pause the video and do it for yourself. Like suppose if I put A here, then I will get 4. If I would have put A somewhere here, okay, then I would not have got anything. I would have got my 3 LCS. So if you want to put the first letter of the pattern, it should be at the first position. Okay, and similarly, for example, the second position of the pattern, it should be at the end. Okay, if you put somewhere in the middle, it won't work. You can just pause the video and just think it yourself. So then you will be able to realize it. Okay, now I will be getting into the problem. So let's solve this problem. So the first thing is that you have to write the code for the longest common subsequence problem. Okay, so you can so I will be just coding it. So for example, so basically if by going by this logic, there can only be 2 cases. Okay, let me just go back. So the first case can be this. I have to count that in this string how many subsequences of AC are present, and the second case will be this string. So the answer should be either one of these. Okay, so now let's code it. So let's write our variable long res1 is equal to 0, long res2 is equal to 0, long. Okay, and in the end, whatever will be the maximum return, I will return it. So return max of res1 comma res2. So this is it. Now what I will do is that I will make a string, say string new text. Okay, new text is equal to this empty string. Now the first case, so the first case will be new text is equal to, so I will put the pattern 0, okay, plus text, this will be the first, and then I will make another function which will give me the result. So let's write that function as res1 is equal to, okay, let's name it count ways. So count ways is equal to new text, count ways, count subsequences, okay, subsequences. This will be the method. So I will put the new text here and pattern here. Okay, so this function which I am going to write will tell me the number of subsequences in this case. Okay, so this will be the first case. The second case will be new text is equal to text plus pattern 1. Okay, let's correct this spelling, pattern 1. So this will be the the second string, and let's store the strings result into this count. I will again hit this function subsequence, count subsequence, new text comma pattern. Okay, so now I have written this, so these two will be my results and I will return the maximum. Okay, now let's write this function count subsequence. Okay, so let's write it long count subsequence. Okay, so let's paste this string s1 comma string s2, and I will so I will pass the references of these two strings here, ampersand, because if I don't pass by reference, then these strings will be copied every time. Okay, so now let's write the size of the strings. So int n is equal to s1 dot size, int m is equal to s2 dot size. I will tell you the importance of this reference later while, because if you don't pass reference by the variable by references, it will give you a time limit exceeded error. Okay, so since this is a DP problem, I have to maximize I have to count the number of substrings. So let's make a vector. So vector int, okay, I will make this vector later on. Okay, I'll make it right now. Vector of vector long dp. I will initialize this vector dp dot resize n plus 1 comma vector long m plus 1 minus 1. So this vector size will be basically, since m is always constant, this is always of size 2, so we can say that this will be a n into n plus 1 into 3 size vector. Okay, so now I will call another function, return count. I will make another function count. So what I will ask this function is that I will give these two strings s1 and s2, and the starting indexes 0, 0 and dp vector. So I will tell this function that, okay, hey function count, tell me the number of subsequences that can be made. Okay, so now this is a very easy function to, not very easy but simple. So I will write this function count and string ampersand s1 string ampersand s2 int I comma int j comma vector of vector long dp ampersand. Okay, so again I will write the size of the strings here because it will come in handy. Okay, so since like this is a DP problem, so this I'm going to solve it via memoization. So so let's say that if so initially I will be starting from here. Let's change the color. Okay, so in this case, suppose this is the string, a is here, I have taken a in the beginning, so I will be starting at this and this. Okay, so if these two match, then I have two choices, that I can say that okay, I will take this letter and I will move to this one. Okay, and or I can say that okay, no, I don't want to take this one, this a, I will like to take this a. So in this case I will put my pointer here at this a only, and I will move my this pointer to here. Okay, so let's write it. So these are the choices, and the problem will end, the base condition will end when, suppose if this pointer comes here, it means that a subsequence AC has been found. Okay, I will keep on moving these pointers, uh, and so this will be the base condition. Or another condition will be if this pointer comes here, it means that I was not able to find any subsequence of AC, so I will return 0. So I mean, let's code it then. So the first part will be the base condition, the second will be choices. Okay, so let's write the base condition. So the first base condition will be if j is greater than equal to m, then I will return 1. It means that I have found that subsequence. J is the pointer for this s2. Okay, s2 is our pattern. So this is the first condition, and the second condition is if I is equal to n, then return 0. It means that you are not able to find any subsequences by the choices you have taken. So now let's write another thing. So if so whenever I am moving these two pointers I and j, it can happen that these will match. Okay, so if these match, so that is basically if s1i is equal to s2j, in that case I have two choices. So uh, return let's say count uh, s1, s2, I plus 1 and j plus 1. So I mean, this is the first choice that I can take, and the second so in this choice basically I am saying that okay, I am accepting this a, I am taking this a for this subsequences, and I am moving both of these pointers, so this will give me one result. Okay, and the second thing can be I commit this pointer and I say okay, this is matching, but I don't like to consider this a in part of my subsequence. I will like to take this a. Okay, so if I take this a, I can make these two subsequences, so I will get a result 2. And if I consider this a and not this a, then also I can make another two subsequences, so total will be 4. So I have to add both of these results. Okay, so I will add it. So count s1 comma s2 I plus 1 comma j comma dp. I have not memoized, I am just writing the recursive code. I will memoize it once I have written the choices. So in this case I will give the sum of these two, and if they don't match, then I will have only one choice, that is to move on. Basically this thing, my this j, because since it is not a match, I will not move my pointer j, I will just move my pointer I plus I am making it I plus 1. Okay, so this is our code. Now let's compile it. Hope everything is fine. Something is a spelling mistake. Resize. Another spelling mistake, line number 48, pattern. Okay, I hope there are no more compilation errors. Okay, so yeah, I can safely say that the code is looks good. So now I will memorize the code. So whenever I get a result, I will write it like dpij is equal to count, and dpij is equal to count. And if I find this result, if dpij is not equal to -1, return dpij. Okay, let's submit it. Okay, so it got accepted. Basically this problem is just I have to calculate the subsequence for these two cases, res1 and res2, and I have written this function just in order to initialize this dp vector, because for this count subsequence the dp vector will be different, and for this time for calculating res2 dp vector should be different. So I will reinitialize this dp vector here, and I will write the subsequence code here. So basically this problem was a part of two problems. First one was the observation that you have to put a here in the end of the first pattern, in the end or the beginning, which can be deduced from the time complexity given here. So another important thing I want to refer is that see here s1 and s2, the text is not changing. Okay, so if I do not pass the reference, okay, uh, then the code will give a time limit exceeded. Mm, mm, mm. Okay, okay, memory limit exceeded. uh, I faced TLE here. MLE. So it is giving memory limit exceeded. So I just want to say that if these strings are not changing, then I will suggest that you should just study about this when MLE happens. And my suggestion will be that always prefer when these things are not changing. Okay, then it will be better idea if you pass it via reference, so it will not create additional variables for s1 and s2 in each recursive call. So that's all I want to say, and if you like the video, understood the problem, please do subscribe the channel. So thank you and have a nice day. Bye.